There's a magnet on either side of the glass wall, and it is capable of doing work. It carries that magnetic charge across the glass, and it's lifting a diamond ring up. It's doing enough work to lift a diamond ring. And this is through a layer of glass. Okay, the little round magnets over there on the other side of the glass, and my big bar magnets here. And this is not touching each other. They don't touch at all. It's held by a magnetic field through the glass. It doesn't. It causes some lessening of the magnetic charge or strength because it does not. Glass does not participate in the magnetic field. Silicon dioxide is what glass is made out of, and it ignores magnetic fields because it has no inherent charge unless you change it, right? I mean, squeeze quartz and it will produce electricity. It produces a charge. And that is, in fact, how watches and clocks use quartz as a method of timing the clock, because it builds up and releases, builds up and releases at a very known rate, and we can build machines that use that. Piezo or piezoelectricity. Piezoelectricity is caused by squeezing the quartz or running a coil around it and having a magnetic field squeeze it, and we can then and it grows, it pulses, and that pulsing, that mechanical pulsing, is what times watches and clocks. So it's usable, but this is what physicists call action at a distance. I am moving another solid object without touching it. And I don't know how it happens. I do not. I can describe all of the phenomena going on between the two. I can describe how magnetic fields are created in certain quanta. The further out you go from the magnet, the lesser the attraction is, at a rate of the inverse square of the distance and something to do with the amount of charge that the magnet has. And that varies from one substance to the next, and from but this action at a distance That's what that is. I'm moving that bag with the diamond ring in it without touching it. Isn't that amazing? The fields of force go outwards around the magnet. We can see them when we put iron filings in there, for instance. And the iron filings stand up and pay attention when you put them in a magnetic field, and then you can watch them as you move the magnet around. And they show that the magnetic field happens in quanta, in discrete steps. The closer you are, the stronger the attraction. And that is passed on here, even through the glass. Even through the glass. How does it do that? How does it do that? The glass is just ignoring it, right? Like my shirt ignores it. It doesn't do anything to my shirt. It doesn't do anything. But the magnet over there on the other side wants to come over here, and this one here wants to go over there. And so they are attached to each other. See? For sure, they are attached to each other through those magnetic fields inside of there. I'm thinking about it.